Good evening. Tonight we are watching amateur radio satellites presentation by Frank Karnauskas of AMSAT. And this meeting is being recorded. This meeting is sponsored by the AIAA Central Florida section. AIAA National is the largest aerospace professional organization with 30,000 members. We have industry-leading technical committees and forums. The Central Florida section serves the local aerospace community. It encompasses the areas, the counties shown on the slide in Central Florida, and we cover quite an extensive area from in the Central Florida area. The AIAA supports the next generation of aerospace students and educators. We have 2 student branches at the University of Florida and University of Central Florida. And I wanted to announce to everyone that we have a May the 4th, 2022 Spring Awards dinner at the Celeste Hotel. And it's meeting notices are being sent to everyone. We're also having Central Florida section officer elections during the entire month of May. Nominations are open until the end of April. We hold council meetings the second Friday of every month. You can contact aiaa.central.fl@gmail.com to participate. We also have a presence on Engage, Facebook, Instagram, and YouTube. And this presentation is being recorded on YouTube. And I'm now going to introduce our speaker. Let me see.
It look like a slideshow?
Yes.
Okay, we've got the recording in progress.
Yeah, so everything you say is being recorded.
Okay, great. Okay, good evening, everybody, and thanks for the privilege of speaking tonight. When Chris first talked to me, I understood that this was a group of some amateur radio operators and a bunch of other people who were interested in aerospace. I did not know this was the Central Florida chapter of the AIAA. So this would probably be better if I gave, in hindsight, 2 separate presentations, one for the amateur radio operators and one for the general membership. So this presentation is probably going to be not quite targeted to the appropriate audience, but we'll do the best we can here. And always happy to come back again to clarify some questions. So just what I wanted to talk about is just what kind of satellites do hams fly? What do we need to play with our satellites? What is ARIS? Well, I'll tell you what ARIS is. It's the amateur radio on board the International Space Station, which is a very exciting program, and talk a little bit about what's in store for the future. And what's in store for the future is nothing like warp engines and traveling at faster than the speed of light, but we still have fun with our simple amateur radio satellites here. But first, just a little bit of history. You know, AMSAT just celebrated its 50th anniversary 2 years ago. AMSAT was born almost simultaneously with the dawn of the space age, and we got our start because we had some people who had good relationships with NASA and with, I'm not even sure NASA existed then, but with the United States Air Force. And where we got our start was the launch providers, United States Air Force, was looking for ballast. And they would come to us and say, well, you know what, or we would go to them and say, well, we'd sure like to fly a satellite. And they'd say, well, if you have something that's this big and weighs this much, rather than setting up a hunk of steel, we'll fly you complimentary, and no guarantees. You know, you're not a paying customer, but we essentially flew as ballast. And a lot of times we've flown on trial flights of unproven spacecraft, and we do have one or two satellites that are orbiting the bottom of the Atlantic Ocean to this day, where they'll probably remain. But a curious thing is one of our earliest satellites, AO7, launched back in 1974, is still operating today. It was built with off-the-shelf commercial components. Nobody in the government gave it a chance of lasting more than a week or two, but it's the longest operating satellite in history of any type, commercial or government or educational. And it was really an eye-opener for a lot of people, because it gave a demonstration of what a low budget device could do with relaying medical data, analyzing a Doppler shift of ground-based transmitters. This was kind of like the early proof of concept for using locator transponders on downed aircraft and so on and so forth for search and rescue missions. So good old AL7 is still limping along today. She's gotten a little erratic in her old age, but still functioning, enjoyed by amateurs to this day. Okay, so this is the part that's, I'm going to flip through real fast, because you guys probably know this, but I'll try to put it in the perspective of amateur radio operators. And we generally categorize our satellites as the type of orbits are in and the modes of operation. So you guys know this, everything's a CubeSat these days. So we won't belittle that or belabor that fact at all, but typically, you know, the early birds that we flew, some of which were the size of washing machines and Volkswagen Beetles, everything's a 1U CubeSat right now. I'll talk about what's coming up in the future. We've got some 3U birds that are under development right now. But like I said, we generally beg, borrow, and steal our launches. We have a good relationship with NASA, so we regularly get our flights sponsored by them. We've also had a launch recently on Virgin, and that actually made it survive. So we're happy for that. Sometimes the good guys win, you know. But you know, one of the tricks to getting a free ride with NASA is to have an educational payload or a scientific experiment that's of virtue that it should fly. We're not going to get a free ride for a satellite just so hams can talk to each other. No, our satellites have to support some worthwhile scientific or educational purpose. If our payload does that, then our reward is also, by the way, there's a ham radio repeater on board so that we can talk to each other. But depending on who you talk to, that may or may not be the primary purpose for the mission. But all of these do fly, like I said, some educational or scientific payload. A good example of that is one experiment that we've flown is with Vanderbilt University, where they've been testing some components for survivability and the rigors of space. And really simple concept. It's a calculator that keeps running the same calculation over and over and over again. And as long as the calculator keeps coming up with the correct answer, they know everything is working right. If all of a sudden the calculator comes up with the wrong answer, well, they know through a series of calculations where along the computation chain that failure occurred. So that's kind of typical of the payloads that will fly from a scientific standpoint. Always tied in with a university. Besides Vanderbilt, we also flew a mission with the University of Washington last year. Okay, types of orbit. Okay, this is kindergarten stuff for you. But right now, all of our satellites are in low Earth orbit. We are working to get back into the highly elliptical orbits again. That is becoming more of a challenge, primarily because of regulatory issues. Before we started here, Walter and I were talking about the problem of space debris, and now the requirement, if you're going to go into highly elliptical orbits, you need to have some maneuvering capabilities to deorbit the satellite or move it to a safe orbit. That is really expensive and essentially untested territory or terrain for the type of satellites that we're flying. So there's a lot of work that's being done in that area, but that's become a game changer for amateur satellites. Is a requirement to have that maneuverability on board. Finally, the geosynchronous orbits, that'll probably never happen in my lifetime. Keep in mind, I'm 73 years old, so I'm not really sticking my neck out very far. There is an amateur radio payload over the Eastern Hemisphere, but it's actually riding on board another geo satellite up there. But the cost, the technical requirements of, and then the control aspect for a geosynchronous satellite is obviously well outside the immediate capabilities of the amateur satellite community. Okay, so just why is the HEO highly elliptical orbit so attractive to amateur radio operators? Well, if you can't afford to go geo, a highly elliptical orbit is the next best thing, because it does provide generally 12-hour visibility with for the most part, a slowly moving target. So it does simplify the tracking requirements and such. So that's kind of the holy grail that we're working to get back at right now. And just for giggles, for the unindoctrinated, not you guys, I usually compare this, how the highly elliptical orbit looks to the Earth, comparing it to a roller coaster, where the train moves slower and slower and slower, and it almost seems like it's never going to reach the top. And then once it does come over the top, it just screams back to Earth till it whips around again. That's how I present this to non-technical people. I hope you get a giggle out of that, if nothing else. Okay, so again, all of our satellites are low Earth orbit right now. We're working to get back into highly elliptical orbit. So the other way we classify our amateur radio satellites are by the type of modes that they operate. FM repeater, linear transponders, data, telemetry only, and slow scan television. So just a slide on each of these to help you put that into perspective. Our FM repeater satellites are single channel bent pipes. Okay? Typically a UHF uplink, 440 megacycles or megahertz, excuse me, showing my age, and a VHF downlink. Typically, these things are well under a watt. 500 milliwatts is a simple, is a decent usable power level for us. And the antennas are just simple monopoles. There's no attitude control on these satellites. They just slowly tumble through space. One really interesting fact to demonstrate the ingenuity of the hams who built these things, literally in their basement sometimes, is on the deployment of the monopole antennas. They're simply spring wire that's coiled up tightly, tied up in place with some fishing line to a resistor. And when it's time to deploy the antennas, the command station just directs all the power it's got in the battery to heat up that resistor. It melts the fishing line, and boing, the antennas are deployed. not a lot of high technology required to get some of the simple tasks done, but that's how we do it. So FM repeater satellites, really popular, wildly popular with the amateur radio community because the path loss to LEO satellites is pretty low, and with some simple handheld transceivers and a handheld Yagi antenna, you can experience the thrill of space communications. This has been a very popular success story for AMSAT. The linear transponders require a little more preparation and work. These linear transponders are Morse code and voice only. Okay, FM is popular because it's simpler equipment, both in space and on the ground. But FM is a very power-hungry mode. Takes up a lot of bandwidth, so it has its place, but it's not the be-all, end-all. So Morse code and single sideband or voice are much more spectrum efficient, much more power efficient. So on these transponders, typically there's a 30 to 40 kilohertz bandwidth that allows multiple users to enjoy the satellite at the time. Satellite passes are typically about 10 to 12 minutes. So a lot of people can get in there and enjoy the satellite pass. One interesting thing about the transponders is all the users share the power. So for the sake of discussion, let's say it's a 1 watt transmitter. If there's one person transmitting on it, that person gets the benefit of that one watt. If there's two people, well, now they're each getting the benefit of 500 milliwatts, 4 users, 250 milliwatts. That may sound like it's going to shrink the power budget down really fast, but when you consider the waveform of voice and the short duty cycle of Morse code, really that demand of all those users keying up the transmitter is at the same time is actually pretty low. So sharing that power among multiple users really works pretty good. Now, one thing I wouldn't normally inflict on a normal non-technical audience is when I use the term single sideband for voice. Just really quickly, if you looked at an AM radio signal on a spectrum analyzer, you would see in the middle here this tall carrier, okay, that's really consuming about 75% of the power output of the transmitter. The voice intelligence is on these two sidebands on either side, but they're both exactly the same. It's duplicate information carried on both sides. So when we refer to single sideband, what we do, okay, is through filtering at low power, we take out that wasteful carrier that's consuming 75% of the transmitter power and taking out one of those duplicate sidebands so that that 1 watt, instead of wasting 90% of the power, can all be concentrated on that one sideband that carries the voice information. Very effective from a power management standpoint, also very efficient from a spectrum management standpoint. So when you hear hams use that term single sideband, this is how we're conveying that voice information. But most of you probably knew this already. Okay, so there's also a number of satellites that just carry packet data. We hams call it APRS, or automatic packet reporting system. Kids today would call it texting. These satellites are typically built by the United States Air Force and Navy academies, and they're very, very popular because they'll handle a lot of simultaneous users. A packet lasts just a split second, so we can carry on a lot of conversations back and forth. Also, packet operation is on board the International Space Station. The International Space Station ham radio alternates 1 month on a voice FM repeater, and then the next month it'll operate on packet operation. I enjoy the packet operation more because there's not so much competition to get into that one channel that's available on the FM repeater. It's a lot more soothing for my nerves. Finally, there's some satellites that operate telemetry only. Again, they're typically built by universities and will have some specialized function, like I said, for testing components or some other experiment. And we typically, AMSAT typically partners with the university. They will build a space frame. They arrange for the launch. What AMSAT does is contribute the radio communications and the IHU, internal housekeeping unit, to run everything. So after the experiment concludes, typically these things will run a couple months, maybe 6 months, something like that. When the university is finished with their experiment, they say, okay, we're done with it. AMSAT, it's all yours. And then we use it as a either an FM repeater or a multi-mode transponder. So that's another way that we get our satellites into the air. Okay, on board the International Space Station, this is a huge story for amateur radio. Amateur radio has been on board the ISS for over 20 years now. Virtually every astronaut that flies up to the ISS is a licensed amateur. That's part of their training before they go up to space. Aside from the one radio that I talked about that is used for amateur radio communications, either the FM repeater or the packet repeater, the main purpose for the whole thing is conducting contacts with schools. And the astronauts, some amateurs on the ground, they will go into a competition in partnership with the school to get into the limited number of slots were available. And then they will set up a amateur radio station at the school, schedule a contact with the astronauts, which, like I said, will last about 12 minutes or so. And the students submit their questions, and about 20 students get to read their questions to the astronauts. The astronauts will answer back live. NASA loves the program because it is really a high visibility program, educationally oriented program in the school community. And if you're guessing, the most popular question the kids ask the astronauts is, how do you go to the bathroom in space? You would be right, okay? It's fun to listen to the kids. A lot of these are live streamed, and it's really exciting to see the kids get excited about STEM topics and about aerospace. It's really a cool program. The program had been operating on some old Ericsson public safety handheld radios that were converted for amateur radio use. They'd been limping along for most of those 20 years. Just last year, we did get what we call our next generation radio system on board. It's a converted, it's a amateur radio transceiver, okay, which was made by Kenwood. And Kenwood very kindly reprogrammed the firmware, because sometimes these mobile radios are very menu deep, menu. And if you're not paying attention or working with this every day, it's easy to get yourself lost. No one wants to have to zero out the firmware and start from scratch. So Kenwood, at no cost to the amateur radio community, reprogrammed the firmware on that radio to make it, we jokingly say, astronaut proof, because those men and women up there are very busy. They can't take the time to become highly proficient in this. So they've set the menus up so that it's very, very foolproof. They can keep the radio system operating without having to spend a lot of time going through menus and changing different settings. The interoperable power supply is a work of engineering genius, providing different voltages for upcoming experiments that we'll be sending up there. Okay, and one of the key elements of the design was to have USB power ports there because the astronauts are always looking for places to recharge their tablets. So we figured if we had some USB charging ports, that might be an attraction for them to come to our radio station up there. Okay, and there's an example of the astronaut-proof radio system. Of course, I say that astronaut-proof lovingly. Like I said, they're just really busy up there, and we have to make their job as simple as possible. Okay, I also mentioned slow scan television. Boy, in the day and age of 4K Ultra HD TV, this may seem like a Stone Age mode, and it is. Okay, but again, it's simple to do. You can use the most rudimentary radio equipment and download these pictures. They will schedule these special events for like 3 or 4 days, something like that. Then they'll have a dozen images uploaded into the system, and the system will just keep repeating these slow scan television transmissions. Each frame lasts about 2 minutes. 2 minutes in on, 2 minutes off, and it's people have a lot of fun going out there with their handheld radio, waving around their little 3-element 144 megahertz antenna and capturing these images. And if you do that, there's a club in Poland of all places that will send you a nice certificate if you can document your receipt of these. So that's a really popular activity with hams who are involved in space communications. Okay, so that's what our satellites look like very quickly. What do you need to play? Well, you need to predict the orbit. You're going to need an antenna and a radio. And that pretty much sums it up. What's widely available are some satellite tracking apps that are available for both the Android and the Apple world. You can load in all the satellites that are of interest to you. It'll give you the acquisition time and azimuth, peak time, azimuth and elevation, LOS, azimuth, and give you a geographical representation of what that satellite pass is going to look like. So this is typical of what these screens look like. It'll list all the upcoming passes. You pick the one that's of interest to you, tap on that, and it'll show you what the path is going to be on the next screen. So it'll help you pointing your antenna in tracking the satellite if that's the path that you're interested in. Okay, and all you have to do is Google satellite tracking apps, and a whole list of these will come up. Give you a hint though, ISS detector is probably one of the more popular ones. Its name belies its power. It tracks more than the International Space Station. It will actually load any amateur radio or commercial satellite up there, even the NOAA weather satellites. If it's flying up there, you can load that in there and predict the satellite passes with that. Okay, as you get more deep into the hobby, there's a couple of desktop apps. SAP PC32 for the Windows world, and Mac Doppler for Macintosh Apple users. One other thing that these programs do, aside from giving you the same kind of graphical display of the upcoming passes and what the radar view is going to be. These desktop satellite applications, tracking applications, will also control the elevation and azimuth rotors that a lot of hams use for their higher gain system. Okay. So I'm going through this information pretty quickly. I want to point out some more information you can go to. By the way, if you do decide to download one of these apps, they're absolutely free, and you want to try that out. One thing you may want to do is, if you're looking at the amateur radio satellites, okay, is go to AMSAT.org, okay, click on satellites, and you'll get kind of a real-time history of the health and welfare of those satellites and their operational mode. I say that because depending on the satellite mode, whether it's in eclipse mode or whether it's in full sunlight mode, or sometimes it's they've changed the UHF up, VHF down to some other configurations. If you're tracking a satellite and you're listening and saying, well, why aren't I hearing anything? Before you actually do that, you want to go to AMSAT.org, click on satellite, and look at the current reports that'll tell you, okay, are other people hearing this satellite or not? Okay, if I'm not hearing it, there's probably a good reason for that. So this is a good way to double check what the prediction apps are telling you. Okay, talk about antennas really quickly. Basically, if you're using a portable antenna, this arrow antenna is both a 3-element VHF, 7-element UHF antenna connect to your handheld. And yes, that person is talking to a satellite with that simple equipment. Okay. And when you're ready to invest a little more money, you get into the circularly polarized arrays with the LAS control on them. Even though the satellites are linear polarization, just with the monopole, because there's no attitude control on them, they are slowly tumbling through space. So by having circular polarization on your antenna, no matter what the relative polarization is for the satellite, you're going to have a good strong signal. You won't experience any deep fading that you would with just a linear polarized satellite antenna on the ground. Okay. There's also omnidirectional antennas that are circularly polarized. These kind of work okay. You know, you're not going to grab those low passes skirting the horizon, but for most of the higher passes, these will just work fine, and they're not particularly expensive either. Okay, this is not the Martian surface. This is actually near my house in Tucson, and this is just a picture I threw in here to show you that a friend of mine and I were testing the antenna on the left here is a commercial antenna that cost about $450. The antenna on the right here is one that Kurt built with some old antenna arrows and 3D printed some brackets. It cost him a couple bucks to build that, and both antennas performed essentially the same. So that was a fun little experiment. The $450 commercial antenna, the aluminum arrow shaft antennas built in Kurt's shop. Okay, as far as radios go, there's really no end to the amount of money you can spend, as with any other hobby, but really simple handheld radios that are in the neighborhood of $100 or so will allow you to work the FM repeater satellites. You can spend a little more money to increase your power and your versatility. And then if you're going to talk to use the satellites with the CW, the Morse code, or the voice transponders on them. It's now you're getting into $600-700 or more to play with that game. Okay, that's all I'm going to say about that. You know, some friends say, "Well, God, Frank, that's an expensive hobby," and I say, "Well, how much did you pay for that Harley Davidson Softail that you drove up here?" Everything's relative, right? And so on and so forth. If you're going to operate out on the field, you need a compass. When those satellites come by, you got one hand on the radio, one hand on the antenna. Little voice recorder is handy to have so you can listen to the contact. You don't have to worry about writing down or logging your contact as they go. And headphones are a must. One thing I haven't said so far is a duplex operation is essential because as you're transmitting, you also need to be listening to the downlink signal to make sure that you're actually hitting the bird. You have your antenna. If you're using a handheld antenna, you got the boom twisted, so you're matching the polarization of the antenna. And if you're not using headphones, you're risking getting feedback, which will incur the wrath of everybody else trying to listen to the satellite on that pass. Okay. So again, I've been flying through here, and you know, Walter, I'm sorry I didn't look at the time when I started here, so I don't know how long I've been jabbering, but fortunately the end is near here. But what I want to say is, if you're interested in getting more information about amateur radio satellites, go back to AMSAT.org, click on the education link there, and there's a dozen or so articles on how to get started in this really fascinating aspect of amateur radio. Or you can go to the store, and for $15 you can download an electronic copy of Getting Started with Amateur Radio Satellites. It's about 194 pages, and it's really a really great tool for getting started in the hobby. Okay, future satellites, I think I've already mentioned this. We're working hard to get back into the highly elliptical orbit game. We call that our golf program, greater orbit, larger footprint. But again, the serious obstacle to overcome isn't getting the launch, it isn't building the radio, it's getting the maneuverability into a 1U or 3U CubeSat. That's going to be the big challenge for the next couple of years. Just want to mention, and wrapping up here, that AMSAT is launching a youth initiative. We started developing this 2 years ago. I'm the chair for this program. It's a direct to students to parents program. It doesn't go through the schools. Schools are welcome to use it, but we find oftentimes schools are more a barrier than a conduit to getting these materials to the kids. It'll provide them with at-home access to experiments, some online software-defined receivers that are special interfaces to allow them to access the satellites from their tablets or their computers. And what's different about this approach is that we're not going in there selling amateur radio per se. We're going after the kids' interest on things that are already important to them, like climate change, environmental protection, conservation of natural resources and such, things like that, and show them how satellites play a vital role in the management of these problems. And we use amateur radio as a tool for them to partake in these experiments. Hopefully that way we will encourage some of them to become more interested in amateur radio, and is a learning opportunity for them. We operate, we have a trademark KidSat for the younger kids, and BuzzSat for the teenagers and college age kids, and we'll be formally launching that program next month at Dayton Hamvention, as a matter of fact. Okay, I think I mentioned this, the orbiting debris, the collision avoidance. We've talked about one other thing we're working with the FCC, and that is indemnification. And that currently in the amateur satellite service, a live real person must be the licensee, and that person assumes that live real person assumes the financial liability for any damage that the satellite causes. Well, who wants that job? So we're working with, communicating with the FCC to try to get that changed so that an organization like AMSAT can be the licensee and remove any individual person from having to bear that indemnification responsibility by themselves. Okay, by the way, okay, last thing here, help wanted. AMSAT is a 501c3 organization. It is a 100% volunteer-based organization. There are no paid employees in the organization. We're looking for some RF engineers that work with a team of about 10 or 12 people. We're asking that you commit to 5 or 6 hours a week. And if you've got knowledge of analog and digital communications, FM, PSK, FSK, and we'll be playing in the VHF, UHF, and 1.2 gig range. We would sure appreciate your sending us an email and talking to us to see if you would be interested in working with us. We also need a mechanical engineer, at least one mechanical engineer, same routine, 5 or 6 hours a week. We are developing a 3-use space frame with deployable solar panels. That'll be a first. Okay, and then the other typical mechanical engineer responsibilities: analyzing the thermal characteristics, managing the thermal management system, preparing and overseeing the environmental testing procedure, and of course, everyone's favorite job, managing the documentation. So if you're interested in sharing your expertise with us and can spare a couple hours a week, send a note to volunteer@amsat.org. We would sure love to hear from you. Okay. If there's any questions, I think this is just a filmed or video recorded presentation here. So if you have questions or comments, don't hesitate to send me an email, N1UW, that's my amateur radio call sign, at amsat.org. Okay, Walter, how do we do?
Okay, well, thank you so much, Frank. I have some questions. This is still being recorded. One comment, you said that, I got a question and a comment. The comment is, you said that getting to GEO is a big problem because of satellite maneuverability. You know, basically it's a technical deficiency, correct? That you're seeking to overcome to get GEO capability?
No, highly elliptical, HEO, HEO.
Well, I thought your slide showed that GEO or GSO, GEO was a problem, that not in your lifetime.
It's mainly a cost for GEO. It's a cost factor.
Okay, well,
if now the GEO satellite that I mentioned that's in the Eastern Hemisphere, as I said, that's not a free floating vehicle. That's actually just a unit, a module that's strapped onto a commercial package. So they went along for the ride. The amateurs don't have to manage the positioning and the health of the mothership.
Well, I would offer that the aerospace community, I know some people that are working on CubeSat maneuvering and propulsion. If that's a technical obstacle to you, the aerospace community has resources and capability to to address maneuvering and including highly elliptical orbits, if that's a, in other words, am I to understand that you're held back or don't have the resources to maneuver HEO satellites, or?
My understanding, okay, and remember, I'm the person whose engineering career ended with his first calculus course many years ago. My understanding is that the FCC's requirement for a maneuvering system is that it be a proven one.
Oh.
So yeah, we're watching many different technologies out there, but I think the stumbling block right now is none or only some. Because this is being recorded, I don't want to say something terribly out of character, but my understanding is that the FCC requirement is that they be proven maneuvering capabilities, and finding one that's affordable to an amateur satellite program is probably an issue.
Yes, it is, because there are a lot of technologies that are proven and they're expensive. I understand that. Well, at any rate.
Yeah, but we have an engineering team, who's smart enough to deal with these things. But offline, I'd be happy to put you in contact with the engineering people that would sure appreciate hearing from you, Walter, or anyone else.
Yeah, well, as we publicize this video and advertise its availability on YouTube and AIAA Engage website, we'll see what feedback we get in that regard. I had another question about how many satellites do you have? Like how many total AMSAT satellites are there in operation right now?
I'm going to say 4.
Oh, only 4 as opposed to a dozen.
Right. We've got some FM repeater satellites that are coming to their end of life mission, but the amateur satellite game is an international game. The screen that I have back up there again, that are all the currently active satellites that are operating today. So some are Chinese, some are Japanese. There's a Spanish satellite or 2 up there.
So really, that looks like about 35 or so satellites that are amateur radio capable.
They are, yes, they are all amateur radio capable. And this is an international hobby, not just United States based.
Yes, of course. Huh. Okay, well, being from my experience, you showed the antennas and all that. I remember seeing, amateur radio conventions or gatherings where they would have a big, long, like a telephone pole size antenna on somebody's roof, and that was their antenna, and so I guess kind of maybe a simplistic question to you. Those old style antennas, so in other words, you used to be at the mercy of, without satellites, back in my father's days, you were at the mercy of ionospheric waves getting to your receiver, right?
Right. Yeah. Without satellites, typically when people think of amateur radio, they think of shortwave, anywhere from 3.5 megahertz up to about 50 megahertz, something like that. And those are affected by solar activity, temperature, humidity, things like that, that will cause the signals to reflect off different layers of the ionosphere, and that that's what typically gives shortwave radio its long distance powers.
Yes. Well, one of the things I was thinking for amateur radios in a disaster situation, we would have to rely on amateur radios for critical communications. If there was like a national blackout or something, I would assume amateur ham radios would be very valuable.
Yes, and the reason for that is amateur radio operates without infrastructure.
Right.
It's point-to-point communications in its purest form. It doesn't require repeaters, or it doesn't require the internet. So,
right.
Yeah.
Well, what about in Ukraine right now? You would think that, you know, they're basically being invaded, and they're losing their infrastructure. So I'm just wondering, I don't know if you know anything about any ham radios in Ukraine that are staying alive.
All I know is that the government, Ukrainian government, put a ban on amateur radio operations in the Ukraine.
Oh, they did? They have? That's interesting. This was some time ago?
Pardon me?
This was some time ago? Or
Well,
just
since the start of the war.
Oh, since the start of the war. Oh. There must be a war-fighting reason for that. Okay. I don't know the specifics, but that's very interesting.
And I have no idea how that's being enforced. You know, it's anything I would say would be pure speculation.
Okay, well, I'm going to, Frank, I appreciate I don't have any more questions. Do you have any last comments before we close this session?
No, I'll just throw this last slide up here one more time. If anybody does have questions or comments, if I don't have the answer, I can connect you to the person who does. And again, we really would appreciate talking to anybody who's willing to volunteer some time, either in the RF or the mechanical engineering world.
Yes, sir. Well, we'll circulate this with the two sections in Central Florida and the Cape section, and we'll see what kind of feedback we can get. We got hundreds of members, and they'll each be privy to this recording.
Great.
Thanks, Frank.
Thank you, Walter.
Well, okay, I'm going to pause the recording now because I don't have any more questions. Okay, I'm